Hello everyone, happy learning. In this video we will discuss about HMM, that is Hidden Markov Model. HMM is a statistical model. So first question is, what is a statistical model? A statistical model is a mathematical way to represent real world data using probabilities and statistics. So we're using here probabilities and statistics to represent the real world data. And in this model, we will use numbers, probabilities, and data patterns to explain or predict something. And here you can see simple steps how statistical models work. First, these models uses data from the past, then find out patterns using probabilities, and after this it will predict or explain further outcomes. Now let's try to understand this using a simple example. Imagine we want to predict tomorrow's weather. So we are doing here weather prediction and we want to predict tomorrow's weather. So here from the past data we can find, you can see here 70% chances it will be sunny and the probability it will rain, we have 30% chances. Now let's take another example. We have handwriting recognition system. Now let's see how this is related to HMM. Now suppose this system sees a curved stroke. So from the training data you can see here we have a curved stroke. Now we will find the probability that this curved stroke is C, or this curved stroke is A, or this curved stroke is any another letter. So first you can see from the training data we have the probability of this curved stroke, that is C, it is 0.8, that is 80%, and probability that the curved stroke is A we have 0.2, that is 20%. So as you can see 0.8 is greater than 0.2. This means that the curved stroke that the system says it can be C. We have the greater probability for letter C. So this is the probability based decision done by using statistical model. So in statistical model we have just data, that is the past data, plus we are using probability and then we are making the predictions. HMM is a statistical model used to analyze sequence data where the actual states are hidden, but we can observe some outputs. So we are doing here observation. It is called hidden because we cannot observe the actual state. We can only observe the outputs generated from those states. So in the previous example during weather prediction you can see we have hidden states, sunny and rainy. So observations for this example we have here people carrying umbrella or not. So if many people carrying umbrella, it is likely raining. Now you can see here the main components of HMM. First we have hidden states. Hidden states means the real state cannot directly see. For example, letters in handwriting, C-A-T, for example. Initially they are hidden, we cannot see them directly. Second component we have here observations. It means the visual data produced by the hidden states. For example, we will see the pen stroke, sound signals or motion patterns. Third component we have here transition probability. That is the probability of moving from one state to another state. For this example we have the probability of moving from letter C to letter A. Fourth component we have here emission probability. That is the probability of observation of given a state. So example, the probability of the curved stroke that the letter is C means we are finding the probability for the current letter that it can be C. For example, probability of the curved stroke means letter can be C. Last component we have here initial probabilities, pi. That is the probability of starting in particular state. So for handwriting recognition example we have hidden states C, A, T. So initially these states are hidden. So what we will do in second step we will perform here observation. So initially you can see these states are hidden. We cannot directly see the states. So we infer it. Second step we have observation. For observation we have curved stroke for letter C, angle stroke for letter A, vertical stroke for letter T. So here the system observe and uses probability to predict the most likely letter. The system initially don't know what letter it is. So the system is using here the observation. It observing the strokes using the probabilities to predict the most likely letter. And next you can see the algorithm that we use to find the most likely sequence of hidden states given in observation. So you can see this algorithm we will use here, Viterbi algorithm in HMM. This algorithm works by calculating probabilities at each step. So at each step we will calculate the probabilities then by keeping the maximum probability path. So after calculating the probabilities for each step we will keep the maximum probability path and then we have the backtracking to find the best sequence. So this is a dynamic programming algorithm that is used in HMM to find the most likely sequence of hidden state given a sequence of observation. So we have given just a sequence of observation and this algorithm will find out the most likely sequence of the hidden states. And this algorithm also tells us the best possible hidden path that explain the observant data. And we will use this algorithm to see observation like sound signal, pen stroke, motion data. And this algorithm also help us to answer what is the most possible hidden state sequence. Here you can see different HMM applications. We can use HMM for handwriting recognition, speech recognition, gesture recognition, DNA sequence analyzing, and in NLP for part of speech tagging. Now we will discuss three main problems in HMM. First problem that we face it is the evaluation problem. It means we have given a model and observation. So in evaluation problem we have given a model and observation. We have to just compute the probability of observation sequence. And this we can done using the forward algorithm. Next problem we have here decoding problem. Suppose we compute all the probability of the observation sequence. Now we have to find out the most likely sequence of hidden states. And for this we will use here Viterbi algorithm. Third, we have the learning problem. We have to learn the model parameters from the past data. So we have given the past data and have to learn the model parameters. For this we will use this algorithm. Now we will take simple example. Now step by step we will discuss how HMM is used in handwriting recognition. Now let's try to understand this. Now suppose someone writes the word cat, C-A-T. So when a person writes on tablet, that is digitally scanned, we don't directly see the letter clearly. Instead, the system will receive pen stroke coordinates, that is XY points, stroke direction, or speed of writing, or pixel pattern. So these are called observations. So we cannot see the letter directly. So we are doing just the observation, but later it could be. So we have the actual states, they are hidden. Actual states, so we have the actual letter C-A-T, they are in the hidden states. We cannot see them directly. We are just doing the observation. We are observing means the system is observing the pen stroke in the coordinates, stroke direction, speed of writing and all. So we are doing the observation. Now question is how HMM works here. So we have hidden states. In the hidden states, we cannot see the letter directly. So each letter is in the hidden state. So in step 1, you can see we have 3 letters and all 3 letters in the hidden state. State 1, C. State 2, letter A. And state 3, we have letter T. Now we will perform here observation. So system receive features. So it's the next step. So initially we have all the hidden states. Now second step we will perform here observation. So system will receive features like curved stroke, that is likely C. Triangle shaped stroke, that is likely A. Vertical plus horizontal line, that is likely T. So these visual patterns are the observation generated from the hidden states. So here you can see these are the observation that are generated from these hidden states. Next step we have the transition probability. So transition probability tells us the likelihood of moving from one letter to another letter, or we can say one state to another state. For example, the probability of moving from letter C to letter A. It means probability that letter A comes after letter C. Next you can see the probability that letter T comes after letter A. Transition probability helps enforce valid letter sequence, that which letter comes after which one. Step 4 we have here emission probability. So here in step 3 we have the transition probability, that help to maintain the logical order. The next step we have here emission probabilities. It means this tells us the use. This tells us the probability of motion pattern given gesture. So here this tells us the probability of the curved stroke, it could be letter C, probability that the triangle pattern, it could be letter A, and the probability of vertical and the horizontal stroke, it could be letter T. So it measures how likely a stroke pattern belongs to particular letter. So we are checking, just measure the stroke pattern that belongs to particular letter. So what the HMM does here, first we have just given the observed. So first we have given the observed stroke sequence. Here we have curved stroke, triangled, and the straight stroke. HMM calculate what is the most likely hidden letter sequence, and using Viterbi algorithm it might decode all the letters C, A, T, even if the handwriting is messy. So here you can see the simple comparison. For example, we have 3 different applications in the handwriting recognition, gesture recognition, and speech recognition. In the handwriting recognition, you can see the hidden state, we have letters. In the gesture recognition, we have the hidden states as the gesture names. Observation in the handwriting, we are doing pen strokes, and in the gesture, motion coordinates, and in the speech, we have the audio features. So key idea, so what we are doing here, we will see the observation, then we guess the hidden states. So HMM find the most likely sequence. So here we will see just the observations. HMM using states, observation, transition probabilities, emission probabilities, and initial probabilities to model sequence. An algorithm like Viterbi algorithm, forward algorithm, and Bloom-Welch algorithm, it help in decoding, evaluating, and learning the model. And HMM is widely used in applications such as speech recognition, handwriting recognition, natural language processing, bioinformatics, gesture recognition, and all. So although modern AI models like deep learning and transformers are now more common, so HMM is basically used for the sequence modeling in AI. So in AI, we are using HMM for the sequence modeling. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.